Hello everyone, I welcome all of you for this IGBC AP exam preparation course. Myself Saravanan J. Bharati from Carbon Figure Academy. In this module, we will be talking about lighting and renewable systems. So if you take a different typology of buildings, which contributes maximum to the electricity consumption. So from the pie chart, we can able to understand industry, agriculture, and buildings and other sectors. Out of all these, industry holds major contribution, right? So next to industry, we have buildings, right? So buildings consume significant amount of electricity as a energy major energy consumption. So if you take building separate entity, and if you can split it further, we will have residential units and commercial units, right? So among these two, residential units contributes more to the energy consumption. So if you take a typical residential building, what are the different sources or reasoning for electricity consumption? So we have four different contributions. One is air conditioning, second one is lighting, third one is miscellaneous equipment like all our electronic gadgets, then ventilation fans, right? So if you see the percentage wise split, air conditioning HVAC holds 60 percentage, whereas lighting 20 percentage. So if you want to focus on reducing your building's energy consumption, then you have to focus primarily on HVAC systems, secondarily on lighting. So in this module, we will be talking about that lighting aspects only. So there is an interesting fact that 50 percentage of buildings that is going to exist in India between the years 2037 and 38 have not been built yet, which means you can able to understand how rapidly the infrastructure development is being happening, right? So in case of lighting systems, we will have the core physics into the picture, right? So we should understand what are the different wavelength based lights are available and how they are being mentioned technically, right? So we have a visible light bandwidth between 400 and 700 nm nanometer, so within which we have the visible light, that is we are splitting into different colors like violet, blue, green, yellow, amber, orange, and red. So that's the thing. So apart from this visible light band, we have like gamma rays, X-rays, UV, infrared, microwave, radio wave. So their wavelengths and all depending on within falling within the range like 10 power minus 16 to 10 power 8. So that is the typical wavelength in terms of meter, like. So from that end, gamma rays, it would be short wavelength, high frequency, high energy. So on the other end, it would be long wavelength, low frequency, low energy, right? So that would be the benefit of usually being mentioned as for radio waves. So they don't need much energy, but they have long wavelengths, right? So that's how light and respect to energy is being depicted scientifically. So when you would like to tabulate these things based on the wavelength range 380 nanometer, so that would be the starting phase, we can say, under the visible light bandwidth. So 380 nanometer to 450 nanometer, that would be coming under violet or blue. So they are if you see the associate light type, they are cool light, right? Then what are the typical application? Offices, task lighting, right? So how it impact on occupants? Enhances alertness, ideal for work environments. So by understanding this, you can effectively implement the certain type of lighting systems in your workplaces, workplaces, in the sense, in your business places, the work might be anything like an office, restaurant, theaters, malls, according to the place and function. So you can decide upon which sort of lighting you should prefer. So for example, if you take green, its wavelength falls between 495 nanometer to 570 nanometer. It looks like a neutral white light, right? So general indoor lighting and offers a balanced effect, neither too warm nor too cool, right? So then bandwidth 620 nanometer, the at the other edge. So it would be coming under like red color perception. So very warm light, mood and decorative lighting, and it can be used for ambience and relaxation, right? So in the context of lighting, so there are certain terminologies are there with which that different characteristics of lighting system are being perceived. So in typical given buildings, we can have a split of like day lighting and artificial lighting. So day lighting is nothing but natural sunlight passing through some windows or glass based surfaces into the building areas. Artificial lighting in the sense all electrical lighting systems, right? So basically, how the color of lighting is being perceived, we have a measurement called color rendering index. So it is like CRI. So it has value between 0 and 100. So based on the value, we term it as like warm white, cool white, and daylight. And certain category, certain range as poor lighting, certain category like window like 60 to 85 as good lighting, 90 to 100 as excellent lighting. So why this measurement, where this would help? So how the occupant inside your building receives the lighting, so how much percentage of lighting they are exposed to, based on that their functionality, their productivity may be decided, right? So for that purpose, this particular CR index is being utilized. So fundamentally talking about lighting, so we have different terminologies. So from the left side image, we can understand we have a candle, so and there is a flame, right? So from the flame we get the light, right? So from there itself, the first terminology comes luminous flux, right? So which is measured in terms of lumens, right? So how much amount of that light from the flame is falling onto the surface, right? So that intensity, it's called luminous intensity. It is measured in candles, right? So once that intensity of light is falling through a given surface, so we have lux, that is equal to lumens divided by area. So how much area, how much lumens, right? So that is called as illuminance. And luminance, how much light we perceive as a human being with our eyes. So we have candles by meter square. So it's just a visual representation. Let's jump into the table so that we can understand it better, right? So first we have lumens. So it measures the total light output from a source, right? So it is like overall brightness of a light bulb, we can say. So typical example for understanding, so how to perceive this definition, right? So let's skip the third column. You just read it whenever you would like to come back and understand it better. Like let's just stick with the definition and SI unit and example. So lumens, it is being measured in lumen LM. A 60 watt LED emits around 800 lumens. So based on the power, we will have the intensity, right? Total light output, right? Candela, in the sense, it measures the intensity of light in a specific direction, right? So because we have, sphere of directions, so within which, in a particular direction, based on or with the help of some, radian value, angle values, so we can measure it. So it is measured in candela cd. A spotlight may have 1000 candela intensity. Spotlight, I hope understand spotlight. Sometimes people used to say limelight, right? So illuminance, the amount of light falling on a given surface, how well lit it is, right? So it is like lux. 1 lx is equal to 1 lm by meter square, right? So a bright office may have 300 to 500 lux, right? So luminance, first illuminance, that's the amount of light falling on a surface. Luminance, in the sense, brightness of a surface reflecting or emitting light. So illuminance is happening, from the source directly. Luminance is all about how much brightness a surface reflecting or emitting light, so for the benefit of the humans to witness it, right? So candela per square meter. So now you should understand what is meant by candela. It is a measure of intensity of light in a particular direction, same way, right? Because onto a given surface, when some light is falling on, it is getting reflected in 360 degrees, all around. So from where you are perceiving that, and based on that angle, you get different luminance, so that only the candela comes into the picture. So candela per square meter. So a monitor may have 300 candela per meter square brightness. Obviously, we have, holding right now a mobile phone or a laptop or a desktop. If you are sitting straightly, 90 percentage, the luminance might be different. If you slightly, change your head position, front, all around the same laptop, same screen, you may able to receive a different luminance, right? So then color rendering index, it's a measure of how accurately a light source renders colors compared to natural light. So that is the threshold. Based on the natural light, how a light source renders colors, right? So we have a scale between 0 to 100, no unit for this color rendering index, that you should understand. So a CRI of 80 plus is suitable for homes, 90 plus is ideal for art galleries, right? So you may understand, right, based on that example. Then luminous efficacy, it is a measure of efficiency of a light source in converting power into visible light, right? So lumens per watt, it is being mentioned. Then LEDs can achieve 90. So this is where the new lighting technologies are, coming into the picture, uh, with at most low and lower input of power, that is watts. How much amount of, luminance, uh, which means, uh, can be produced, right? Total light output. Lumens means total light output. So LEDs can achieve 90 to 120 lm by W, whereas incandescent bulb offer only 10 to 17 lumen per watt. So now you can able to understand these are the different terminology which would be required to be remembered, especially for the purpose of, exam point of view. So you try to make it as a flow based on your own comfort and understanding from what comes further. Because if you closely watch, all of them, all of these are uh, you know gradually or, indirectly interconnected, right? So based on your own understanding, try to make it as a flow of terminologies and try to remember it. So now after reading all this, if you come back to this picture, now it would be somehow better, right, to understand, especially for non, engineering background people. So we are having different types of lamps and their respective characteristics, and for different aspects of lighting, we have guidelines provided by ASHRAE 90.1 and ECBC India, right? So that has to be taken into consideration, as I already mentioned. So for each and every criteria, the IGBC guidelines would be there. They would have completely providing the aspects to be measured and how to be measured with the help of some table values or some formulas, right? So let's talk about the different types of lamps: incandescent, halogen, CFL, fluorescent T8, then fluorescent T5, might be the versions, upgraded versions, high pressure sodium HPS and LED. So if you simply see luminous efficacy, it's starting from lower to reaching the top, the LED. So far LED itself is getting evolved slowly with gradual advancements. It's a typical LED is being presented here, but in the market we may have different types of LEDs, right? So for example, with respect to the television units, we have OLED, SOLED, SMOLED, right? Lot of the things are there. All are focusing on how effectively that single pixel converts the color to the human eyes, right? So we have subsets of LED as well that you should understand. So color rendering index, it is like incandescent holds most, but LEDs are lowering. But that's what we need. We don't need to waste that much amount of energy, right? So working hours, if you see, durable is LED only. So comparing to all other previous scenarios, like 15,000 to 50,000 hours, LEDs can able to durable long way, right? So in case of guidelines, LPD, lighting power density. So in case of office space, retail space, parking garage, how the value should be. So ASHRAE says that for office space, LPD should be in the range of 0.770 watt per area, right, feet square. So that is lighting power density. So ECBC suggests that enforces LPD limit and encourages LEDs with 90 to 120 lumen per watt, right? So in terms of daylighting, ASHRAE requires daylight responsive dimming in spaces with windows or skylights, right? So dimming in the sense, it's a kind of added feature with respect to windows or skylight kind of glasses, where you can simply cut off the direct penetration of daylight by the help of some wallpaper or screens or some electric based technologies, right? So based on the daylighting, when it is too much of sun, the glass should restrict some of it. When it is so humid and cloudy, then the dimming should be completely off, so that all the possible light from the outdoor gets indoor, right? So ECBC mandates daylight integration in corridors, lobbies and offices. So lighting controls, ASHRAE says sensors to be reduced lighting by 50 percentage in 20 minutes in parking garages. Auto off and on for unoccupied spaces should be there, right? Requires automatic motion sensor in stairwells and lobbies to prevent energy waste. So in terms of energy savings, ASHRAE suggests try to achieve at least 20 to 30 percentage energy savings through efficient integrations, right? So whereas ECBC focuses on LEDs with 15,000 to 50,000 hour lifespans for lower maintenance, right? So in IGBC, it would be both, provided in terms of its own requirement, framework based requirement. So you may need to think about ASHRAE and as well as ECBC. So ECBC would be like a mandatory thing, eventually, for different aspects. But I am not sure about ASHRAE. ASHRAE gives like a threshold, a fundamental ideology about how certain aspects of different electricity consuming operation should be, right? So as far as my understanding, right? So in overall requirements, we can say overall lighting density should be less than 1 watt per square feet, right? So trade off is allowed. Trading off or trade off in the sense, certain areas can have maximum utilization, whereas certain areas can have a lesser or nil utilization of electricity. So that kind of thing you can do. Like if you consider a building, you don't need to worry about the entire building value should come into such value, means certain threshold value, means you can trade off between one floor to other floor, within the floor one particular space to other particular space, right? For example, if the guideline says the maximum lighting power density for space A should be some 50 units, means, but you can't have meet up that 50 there, you have 75 or 65 there, but in other space of the same floor, where the guideline suggests the maximum can be this much, but there you can reduce it, so much there, so that you can balance the reduction in this space and excessiveness in the other space. So that is the concept of trade off. So that is being allowed, I think, under ECBC and ASHRAE. So maximum daylighting is the intent, ultimate intent. So daylight dimmer controls are expected to be installed in office spaces. Then occupancy sensors, including toilets, so that has to be installed. So at least the in terms of lights, so you should prefer CFL, T5 lamps and LED. So we have different types of lamps here, right? So out of which these are the things which are being recommended. If at all, if you use some other type of lamps, you may not be able to obtain the credit points, right? So we have the focused areas of lighting system under IGBC. Like we have 4 different things: lighting power density, daylighting, exterior lighting power density, and lighting controls, right? So for the first one, lighting power density, so it is a key metric used to measure the energy efficiency of lighting systems in a given building, right? So there are 2 different methodologies are there to come up with the calculation. So it actually expresses total electrical power used by the lighting system relative to the area it illuminates. So that is the lighting power density. So for given area, for 1 meter square, if you want to light up it, how much amount of energy you are spending in terms of watts? That is the lighting power density, watt per meter square or watt per square feet, right? So building area method we have, space function method we have. So building area method in the sense, total lighting power per total built up area, directly you are going into an entire building area, right? So this method calculates the total power used for the entire building. So here trade off, what about the trade off? So with respect to building area method, trade off is allowed, right? Between spaces within the building, meaning areas with the higher lighting needs can be compensated by areas with lower needs. That's what I was talking about. Right? Whereas in space function method, the formula goes like total lighting power for a particular zone, right? So it may be a coffee area, or a lawn, or a reception, or a manager room, or locker room, or toilets, or main sitting area. So that kind of different zones we can have within the office, space. So for each space or zone, how much amount of lighting power is being used divided by that zone or space area. So this method measures the lighting power specific to individual spaces, right? So here it does not allow the trade-offs between spaces. So each area must meet its own specific LPD requirements. So in the right side table, we can understand building area method for different building type and building area type. So we have a cumulative, lighting power density is being provided, right? So post office, transportation, warehouse, because it's building area method means we can come up with only different types of buildings, right, all together, right? So in the bottom table we can have like same interior lighting power for ECBC buildings, which means the fundamental ranking space function method. So here we have different category of spaces, right? So for example, staircase only 5.5 LPD watt per meter square. So that is the threshold within which your lighting system should be there. Then only you can able to array the points under the particular criteria or guidelines, right? So that is the thing. So LPD can be measured by lux meter or power meter or clamp meter. So please note down this one for the exam perspective. LPD can be measured by lux meter, power meter, or clamp meter, right? Because that is how you should document it, right? So during the visit or the site visit or auditing, that might be done by the experts. So just to verify your submitted values, right? So daylighting, we have different key principles of daylighting are there. So it's a practice of using natural light from the sun to illuminate the indoor spaces by reducing the need for artificial lighting, right? So how it can be achieved? There are different ideologies or principles are there. First one is fenestration design. So window and openings are optimized on north facing facades to capture consistent daylight while minimizing heat gains from direct sunlight. So we all know, like, sun rises in the east, sets in the west, right? But we are having a different geographical locations for our different buildings. So what can be done is we should and go for understanding how the sunlight interacts with the typical building. So around the year, right? So including summer, winter, lot of technical terms are there. Some summer solstice, winter solstice. So I have always wanted to learn that particular area. Like, people used to call it as technically as physics of building physics. Like in big firms like L&T, ACOM, so those kind of places, very dedicated engineers called building physicist will be there, right? Just to analyze the daylighting of their building infrastructure projects, right? So that's a very detailed area, but try to understand for the Indian context. We are needing to optimize the windows and openings on north facing facades, right? Where you can able to capture consistent daylight while minimizing the heat gains. right? So light shelves and reflective surfaces, we have other option. So light shelves and reflective interior surfaces distribute daylight deeper into the building's area, so as helping to reduce the need for artificial lighting. Third one is daylight zoning. Spaces closer to windows receive priority for daylighting, while areas that do not require high illumination can be positioned farther away. So this is all about how an office spaces has to be laid out, based on daylight preferences, right? So automation, sensors and automated dimming system can be installed, and they can help in adjusting artificial lighting based on daylight availability, right? So they are like integrated devices, right? So in terms of daylighting, how it is getting measured, so we have the term called daylight factor, DF. So it is a definition of indoor illuminance to the outdoor illuminance under uniform overcast sky conditions, right? So it is like in terms of percentage, I think, or point, you know it is being mentioned. Indoor illuminance divided by outdoor illuminance into 100%, right? So higher DF indicates better daylight penetration indoors, which reduces the need for artificial light. So with respect to the the threshold, achieve a minimum average daylight factor of 2% for at least 50% of the total floor area of all regularly occupied spaces. So that is like the fundamental threshold for IGBC guidelines, right? So here it is a lux meter for measurement of illuminance value. So it's like a handheld mobile phone, huge phone, right? So then another factor called useful daylight illuminance, UDI. So it measures the annual occurrence of illuminance levels within a range that is considered useful by occupants. So it is typically considered value is 100 lux to 2000 lux as useful. So this measurement ensures a balance between sufficient daylight and avoiding glare, so that to improve visual comfort for the occupants. So how it is done? Measurements at a work height of 0.8 meter above the floors, because that is where the tabletops are there. So where that is the height where people normally do their stuff in the office spaces, right? So the period of analysis shall be fixed for 8 hours per day. UDI shall be calculated for a grid size of 1 meter square. So grid size in the sense, if you have a 20 square feet area in your office building, for example, into a room, that 20 square feet area has to be splitted into different grids of sizes 1 meter square each. So for that each block of 1 meter square area, what is the UDI value? So for doing this and all, we don't need to worry about. There are a lot of software solutions are there. We can do it so that we can understand what is the different UDI value for our different spaces, within the context of natural daylighting, right? So these are the different software names: Radiance, Daysim, Grounddog, Diva, Open Studio, Light Stands or Design Builder, so IES, Revit. So these AutoCAD guys will be there everywhere, right? So whatever the application, they will have their own tool. So famous, or whatever I have heard, is Open Studio, Design Builder, and IES, right? So all of these are paid versions. You have to pay a good amount to purchase this, and you can able to find some trial versions are also there in their respective websites, right? So with respect to the daylight requirement, this is the ECBC guidelines for different three type of buildings: ECBC, ECBC plus, and super ECBC category. So different building typology: business, educational, star hotel, you ordinary hotel, resort, shopping complex, assembly. So we have the percentage of above grade floor area meeting the UDA requirement for at least 90% of the potential daylight time in a year. 45 percentage, 30%. So just now for seeing it, you may not able to understand it, but it's all about working in a typical software. You put up the data and it will show up that particular percentage value. So you don't need to worry much, but I suggest strongly that especially if you are interested in lighting systems, you would definitely need to learn about building physics. That is the core fundamental. So there is a NPTEL course which is being offered either by IIT Kanpur, I think, but I am not sure. You can go and check in NPTEL websites. Principles of building science. 4 weeks course is there. So I have tried many times to register and pursue that course, but due to different other reasons, I could not complete that. But that 4 weeks course is the core fundamental that you should understand, right, to perform these high level of applications, right? Because you may not be able to find a proper tutorial, you may able to find proper tutorial for these softwares, but how this software functioning, what's the background theory and all is very important. That is how you can uh, you know become or upgrade yourself as expertise from a being practitioner, right? So you should always know the fundamental theory behind it, right? So that is my guide suggestion. You can try out that. So in terms of the other aspect, exterior lighting power density. So this particular point we have already saw in previous modules. I don't remember in which one we have exactly some. So it is like how the connectivity between the occupants and the eternal natural element is being there. So especially during the night, because of our poorly designed outdoor lighting systems, we may lose the connection between ourselves and the eternal night sky view, right? So which will give you some sort of peace and relaxation mentally, right? So these are the different locations of exterior lighting application, and how much amount of LPD should be there. That is the value you can able to see there. So that is the ECBC requirements on exterior lighting density. So what is the ultimate intention? It is to reduce light pollution from exterior and facade lighting, to increase night sky access and enhance nocturnal environment, right? So we have the last topic, lighting controls. So again, we have space control or automatic light shut off systems, all those things, right? So if you have a lighting, so this is how it would look like. You are working in your desk and you are doing your work. Just above your head you have a lighting, and that can be like workstation lighting or your zonal lighting, right? So you just assume you are sitting along with certain peers in a row, or as in a rounded group manner. So accordingly, each one will have their own above head lighting for their own table, right? So that is called workstation lighting. So within which, depending on timing and what sort of work you take up, you may or may not have a separate task lighting, right? Apart from these two, workstation lighting and task lighting, you may have further provision as room lighting also, right? So now you can able to understand, like uh, with respect to lighting controls, you should be able to immediate access to turn on and off of all these three different lightings, so that each and everyone can have, like, okay, for me, this much lighting is enough right now, so I just shut off the workstation lighting right now. I don't want that much. I can work with this task lighting itself. So that is what the lighting control specifically intends. But we don't mind when you just enter, we just switch on every individual switches we see on the switchboard, and we just sit on our place. So that would be the typical practice in every other workplace. So so that has to be optimized. That's the idea of that green building design, right? So which is like cautiously you have to optimize, right? And it's not about within the risk of losing your work efficiency, like the productivity. You are, no, we don't need to worry about the productivity, we need to reduce the electricity consumption. No, that is not the idea. Keeping the productivity the same manner, or even in increased efficient manner, how we can optimize or how we can reduce the electrical consumption for the, like, electricity consumption for the lighting systems, right? So that is the thing. So then we have renewable energy systems. That's the wind up for lightings. So in renewable energy systems, we have different options like sunlight, wind, rain, which means hydropower, tides, waves, geothermal, right? So surprisingly, within the Indian geographical context, we have access to all these other renewable options, but their intensity of how much we can take them out for the actual usage is varying, right? So we do not have 100 percentage potential to take up the entire geothermal energy we have possessed in our geographies, right? But there and there, so if you go to the Ministry of Renewable Energy, you can understand how much each type of renewable and something is not being mentioned here. Bioenergy is there, like biogas and respective things, but those and all are like highly emerging. They might not be able to useful for a scaled purpose, right? So for scaling, we have the major thing like as the solar currently, and wind we have, right? Out of all other things are not that much being scalable right now. And maybe over the time we may come up with waves based or tides based scalable, or scaled electricity production. So right, so currently we have solar and wind. So they are called as offsite solar, offsite windmill, or on-site solar, or on-site windmills, right? So just like based on with respect to the location of your building, from where, how close you are generating the electricity, right? On your own rooftop means it is on-site, but if you are getting it from a differently located solar park with the help of some dedicated supply lines or general grid lines, then it will be off-site solar, right? So we have different mechanisms in enjoying or incorporating renewable energy systems into our buildings. So that are like power purchase agreement, PPA, open access, like then third one is renewable energy certificates. So a lot of other instruments are also there, but these are all the being top preferred renewable energy instruments, right? So what are they? So in the right side we have the visuals. Let us talk about the table description first. So power purchase agreements, it's a long term contract to buy renewable energy directly from a supplier at a fixed rate, right? So the buyer agrees to purchase energy over set term, securing predictable costs and shielding from market price volatility, right? So, if you are a large organization seeking long term price stability and renewable energy procurement means, then you can go for this PPA, right? So, PPA, it is like in the right side, we have as the top visual, we have like there are clean energy supplier, right? So, they are generating clean energy and they are supplying it to the grid. From the grid, the buyer gets it, right? So it is like how they are paying to the producer, which means the supplier, with the help of PPA established between them, right? On the other hand, renewable energy certificate, open access. Let's talk about the open access. So, a policy framework allowing large consumers to purchase power directly from producers through the grid. So, here it is through the transmission grid bypassing local distribution companies. So, can you able to understand? It is like a dedicated direct supply. In the second picture, you can able to see it is like so companies with high energy demand looking to reduce costs and ensure renewable energy use. So it is like let us talk about the REC, then we can try to differentiate them, right? So in case of REC, it's a market-based instrument representing 1 megawatt hour of renewable energy generated, right? So organizations purchase RECs to claim the environmental attributes of renewable energy without directly receiving the electricity. So, companies aiming to offset emissions and meet green certificate requirements. So, what they are doing, so in the right side picture, bottom most, we see the bottom thing, right? So, there is what to say, the source of electricity generation, which is supplying to the grid transmission system, and from this transmission system it is being sent to the users. There is no REC purchase. So in case of REC purchase, what is happening, somebody is producing the electricity using renewable systems and they are giving it through the grid, and through the grid they are getting it the purchase, right? And the electricity consumers establishes a REC concept, and they are claiming that this much amount of electricity we offset using the particular agreement. So it is not like they are receiving the electricity, they are not receiving the electricity, they are spending the fossil electricity only, but they are paying something to the clean electricity producers in the concept of REC certificates. So normally one REC certificate is equivalent to 1 megawatt hour of renewable electricity, right? So it is like in case of REC in application, for example, let us assume if the company consumes around 10 megawatt hour of electricity for the given year, right, using the local grid. So what they are doing, they can't do anything else with respect to carbon reduction or whatever it is means. Ultimately what they can do is, okay, let's install solar rooftop, windmill, everything. Out of 10 megawatt hour, only 3 megawatt hour they could able to balance it, right? But still they are spending 7 megawatt hour of electricity from the grid supply. So what they are ultimately doing, instead of worrying much, they are just buying 7 renewable energy certificates from the accredited market. Right. So now they can claim out of 10 megawatt hour of electricity consumption in the last year, we managed to produce 3 megawatt hour from the renewable energy on site, and for remaining things we purchase the RECs worth 7 megawatt hour, 7 certificates. So they can claim like for the electricity they generate zero emission altogether. So that is the concept, right? So now between PPA and open access, we can see like open access indicates a policy framework allowing large consumers to purchase power directly from producers through the grid, right? So here the energy is purchased from a renewable source via transmission grid, bypassing local distribution companies, which means the government EB system, right? So they are directly paying and they are directly getting from them. So here might be the fluctuation or price variation will be included, right? You can't fix it through like a kind of agreement kind of things. You just directly get connected with the uh, you know from a renewable energy producer, right? So you just pay based on how much you use. But in case of power purchase agreement, it is going with the kind of establishment, a legal contract, so that you pay the same the clean energy producers for continuous period, fixed period of time as a fixed price. There is no market variability account getting into account, but the supply is through the public grid, right? So it doesn't bypass the local distribution company like governments or other contractors, other subdivisions, right? So that is the difference between open access and PPA. So in India, both things are there. Renewable energy certificate, it's a globally known instrument for using or claiming renewable energy uh, uh, you know installations or applications, just to claim carbon neutral or reduced carbon intensity, right? So finally, if you see the overall picture for a given building, if you would like to achieve net zero energy scenario, what is suggested is by modifying or optimizing your internally spent energy with energy efficient systems, that can be done for 75 percentage. That is a scope, right? So remaining things you can go for renewable energy production, right? So passive strategies, active strategies are there. So under passive strategies you can think about orientation, daylight analysis, accordingly designing the envelope and fenestrations, all those things that can be helpful. In active strategies, we have energy efficiency and renewable energy. That's what mentioned as 75-25, right? So energy efficiency in the sense you can focus on air conditioning system, lighting, auxiliaries, and electrical appliances. That's what we have covered. Lighting system we have covered. So next module we will be talking about the HVAC, right? So there you can understand how to optimize, air conditioning and heating systems. So renewable energy side, you can either go for on-site or off-site. So this is like a abstract picture or uh, the the map for achieving simplified map. I would say it's not so detailed road map for achieving the net zero, but it's a simplified abstract. So by doing this, but this is the ultimate playground within which you have to play, right? So there is nothing else beyond this particular the flow chart, right? uh, so because majorly people don't mind about the passive strategies. Normally when I say this, so many people would think about, okay, how I can reduce the air conditioning. Exactly. So the current update with respect to air conditioning is, yesterday government of India made an announcement that air conditioners and they are going to produce hereafter we'll have the minimum temperature as 20 degrees Celsius, right? Beyond which you can't reduce that. So that's a very great initiative, but the manufacturers has to adhere to that. I hope it will be, right. So that's a great thing, because of which electricity consumption would be considerably reduced. That's a good thing, right. So when I talk about this passive and active, many of you would have been automatically focusing on the active scenarios, right, like renewable energy, but many of us might not interested in passive strategies. But passive strategies has the major hit as a impact maker, right, that we don't worry about, that we normally don't mind about, but that is very very important. So there is a huge scope in learning passive strategies. That's what masters in architecture people would learn under sustainable architecture, right. So that is not coming unfortunately in engineering, civil engineering, but they are coming under architectural domain. So people are learning about how to design a or how to place a door or window in a typical building, so that to encourage natural airflow and natural daylight to penetrate into the building area to the maximum possibility level. And when you are designing a cluster of buildings, it's ultimately huge fun, that how to place different buildings all together, especially if it is a tall buildings, tall apartments, right. So all these things are would be there, and very interesting. So that's the overall picture. So that's it. In the next module we will be talking about HVAC systems. So once again I remind that for each module, in the description box you will be finding a link to module wise quiz as a practice for your exam preparation, so you can make use of that. So once all the modules are covered, and the last module, after the last module, I'll be posting on mock exam and respective guidelines videos also. In that video's description you will find a number of mock exam test links as well, right. So I hope all these would be beneficial for your IGBC exam, AP exam preparation. Thank you. We shall meet again in the next module.